So, all right. Well, we're recording now, and as I mentioned, we are recording this for posterity and for use of the club members. I want to welcome everybody tonight to our very first Hams Helping Ham session, learning more about the NanoVNA. And I'm looking forward to diving a little deeper into this topic and, uh, you know, learning what others have done with it and answer a few questions and ask a few questions. Tonight we have Gary, WNITD, who is the de facto expert in this field. At least is the only one admitted that he has one and actually demonstrated that he knew how to turn it on. Yeah, I was going to say I was going to do a questionnaire first to see who has theirs in there. So with that, I think what I'm going to do is, oh, here we go. H4. Yeah. So where is it? Oh, I have an F in there. So I think with that, maybe we'll kind of kick it off and with a general discussion, and maybe we can talk about the different kinds of nano VNAs. So there was an H, I have an F, and there's a lot of different ones out there. And for those that don't have them, it can be a little confusing to figure out which one you should buy. So perhaps you can address that, start the discussion there, Gary.
Well, there's the NanoVNA H4, and then there's the F, and then there's the it's actually called SAA V2. I think recently they went to a 4-inch screen, but before that they were just 2.8. But it's a 3 gigahertz network analyzer, not the 1.5 or so that the other ones are. And it's completely different architecture. Doesn't use harmonics, so it's more accurate or more dynamic range at the higher frequencies. So. But I think the issue with it was it didn't come with a battery and it doesn't remember anything. You have to calibrate it every time. It doesn't store anything, but it is more accurate and doesn't cost a whole lot difference than the rest of them. I think the F is the most expensive one because it comes in a metal box.
Yeah.
I recently found out that on eBay there's a guy selling metal boxes for these for the H ones, so you can repackage your unit in a metal box if you want for shielding. I think it's limited to the small screen version, not the 4-inch one. So that's a disappointment there, but that's something that's available now. Any questions?
So it sounds like the basic functionality pretty much is the same with capabilities, not capabilities, but the base functionality. But some of the newer models or some of the different models will offer a larger screen and a higher operating frequency, trading off other features in there to keep it in that price range that they want to get.
Well, the F was generally more expensive than the rest of them because it started out with a metal box and a 4-inch screen, and it also has a somewhat different architecture than the H models. And there isn't a lot of good software written for it. It's sort of a orphan. Only the original developer is writing software for it, but for the H models, and I believe now the SAA ones, there have been a lot of firmware development, lots. So they're way beyond what the manufacturer installed in it. So there was a lot of work on the H's.
Gary, I got a question. I'm fairly new. I've just been a ham for a little over a year. I know the unit we're talking about has several functions. Maybe you can go over what some of those are, and because I'm interested in antenna analyzer function, because I just started fooling around with antennas, Could you maybe go through some of the functions that the unit could be used for?
Well, of course, it could be used like an antenna analyzer. In fact, the H models have a streamlined firmware version that's a version -AA, which means it only has the one port that it worries about, and so it does essentially the antenna analyzer functions. But it just cleans it up a little bit, whereas you don't get all the other features. For example, like measuring filters or anything, any passive device by using the 2 ports. Now, so it can do a single port. It does reflection on, which reflection coefficient can be converted to SWR. It's the higher the value of reflection coefficient, the lower SWR. Like a 0 dB reflection coefficient means like all your power is coming back, and that's infinite SWR. And you get if you get at least 20 dB reflection coefficient, you're well below 1.01 SWR. So I think the reflection coefficient is more sensitive, but it's a little more foreign to people. So the SWR is maybe easier for them to look at. And the plot, you can convert the traces. The traces can be reflection coefficient, SWR, phase. It'll show you the phase of the reflection coefficient, and must be some more ones there, but those are the important ones. Then when you add the second port, you can measure insertion loss or gain. If it's you got to watch out though with an amplifier you put in between the two of them that you can overdrive the second port if it's got significant gain. So you normally use a attenuator of known value to keep it to a reasonable value. Also, the output, the signal that comes out of port 1 or 0 in most cases, they call them 0, but it really is port 1, is not a sine wave. It has a lot of harmonics in it, and it's very distorted. And therefore, it doesn't matter to itself because it tunes to only the fundamental or harmonic, and it doesn't see the other harmonics. But if you use it to excite an amplifier, that amplifier is going to get hit with the fundamental and all the harmonics, and if it and so the output will be very distorted. So you have to be concerned about that. If you want to make it clean, you'd have to use some sort of filter to clean up the input to the amplifier. There are functions on the unit that you can use that can measure amplifier linearity and such. Does that answer your question at all?
Yes, yes and no. Here's the thing. I mean, from where I'm at, as far as my knowledge, you think it would be better to just go with a basic antenna analyzer as opposed to one of these nano units?
If you want to spend about 3 to 5 times as much money, yes.
Okay.
Yeah, I have both. I have an antenna analyzer which I spend about 3 to 5 times as much, and that works really well for me. You know, it gives me the kind of display. It has a lot of nice features in, but these devices can serve in that role as well, and give you much more. So I guess it depends on how you want to use it. The reason I got this unit was that I wanted to do a little bit more filter analysis. Low pass filters and so on and so forth, which is beyond it was basic antenna matching, And of course, my antenna analyzer would not be able to do something like that. So
Maybe I can chime in on that too.
Yeah.
Pardon?
Yeah, I think this is an excellent tool for experimenters who actually want to design things and, maybe measure an amplifier, measure a filter. But if you're looking to optimize an antenna and that's all you really want to do with it, I don't think this is your best tool. I think there's other tools you can use that are way easier to use and much more
Yeah.
straightforward.
I
Plus-
agree with Joe. I think that antenna analyzers, they're designed for that. They're dedicated to that. So they're very straightforward to use in that regard. Whereas this is much less expensive, but you have to know what you're doing with it to analyze antennas.
Hey, for $90, it's awesome. But
Awesome.
I also have a one port vector network analyzer, which is a high quality one. It's made by AIM UHF. AIM. I don't know if you guys have heard of them or not. But measuring my antenna using that, which I trust, and measure my antenna using my NanoVNA, I get different results. There's something going on there that I'm not quite willing to say these are as accurate as they need to be. I think they are. They're very impressive, but I was hoping to get better correlation between this and my more expensive VNA that I have.
Why don't you measure resistors with it and see if it's how accurate they are? You can put like 50 ohm resistor and 200 ohm, 250 ohm resistors or 400 ohm resistors to get different SWRs and see how well they track.
Yeah, that's a good idea. I've measured the insertion loss with it using a step attenuator that I designed and built that I know is accurate and is dead nuts on for the insertion loss. But I have not tried it making my own dedicated VisWire like you're describing. That's a good idea.
Yeah, you can just take a bare connector and put these resistors on it and measure them.
Sure.
Another thing you can use this for, which I think the antenna analyzers will also do, is you can measure impedances, components, resistors, capacitors, inductors, because this is a two-port device, you can measure the common mode rejection of balance. Can't do that with an antenna analyzer. You need two ports. And insertion loss of balance and such there. You need two ports for that.
Gary, you mentioned you can measure components. Would this reproduce or replace part of what a multimeter would do?
Oh, no. We're talking about, McHenry or 500 nanohenry inductor or something you want to measure. You can't measure that with a multimeter. A multimeter usually has a capacitance measurement function and a resistance measurement function. Mm-hmm. And there is somewhat, the capacitance at least, has probably got some range over with it, which it works well, and then the rest of the time areas it doesn't work well. The thing with the network analyzer is that you can select the frequency you're going to measure the component at rather than DC, which is what your multimeter does.
Along those lines, Gary, I built just a little fixture that you can screw onto the end of it. You can clip, your component that you want to measure right onto the clip leads here. And, you can measure it that way. It's not, it's probably only good for HF and that sort of thing. But, it seems to work quite well that way. Very handy to use.
Roger, can you pull that up again? What is it? How is that connected?
Yeah, so it's really just an SMA connector here to a BNC, which is kind of convenient for what I had, and then a couple of clip leads here on this side that go to each side of it.
So you just connect those to the two parts of the wire?
Just put each lead on one on each side here and measure a capacitor and inductor or that sort of thing.
See.
I want to make it clear though that no matter what you're going to use to measure the impedance, the antenna analyzer or the NanoVNA, when you do it at a one port measurement like you're showing there, it is you quickly run out of accuracy. If you try to measure a 2 ohm resistor, you won't get an answer. If you want to measure a 10K resistor, it won't be right.
Right.
But if it's between 10 and 200 ohms, it's probably a good measurement. But yeah, there is a way, it's called the S12 measurement, where you measure the component between the two ports. So it's an insertion loss measurement, and you use the phase and the amplitude, and you use an Excel spreadsheet you can feed it into, and you get a better, more accurate impedance. And that's how you measure the common mode rejection of balance. I got a simple thing like you've got.
She's just muted there, Gary, but there you go.
2 SMA connectors connected to 2, just the center conductors you're worried about, and this board connects the grounds, and that's how you measure the things across the S12 to measure higher impedances. But as I say, you got to use the phase and the amplitude, and there is an Excel spreadsheet that somebody has made that makes it easier.
So I think it was Doug, perhaps, who asked this question. You were asking about measuring inductances and capacitance. So there's another way to do it also. And this is another whole meeting. We're not talking about the NanoVNA. I'm not hijacking the meeting. I'm just saying this is a simple way, just something like this, which I bought off Amazon for like 15 bucks, and it measures capacitance, inductance, transistors, diodes. And I've compared the results on this to my nice Fluke multimeter. And this is really, it's impressive. It's a nice piece of equipment.
Which
So,
one is that again?
Yeah, I do have.
I mean, it's not super accurate if you're doing really high quality RF work, but it gets the job done to get you in the ballpark for things. Well, I bought this a few years ago. I don't know if this one's still available or not. The manufacturer is called B-Side, which is probably another company that slapped their label on it, but it's an ESR02 Pro, ESR02 Pro here.
I've got this little thing that I talked about in the last, maybe the first presentation.
Yeah, similar.
This one does
Sure.
Resistors, capacitors, semiconductors, the whole bit here, but it's fairly accurate, but it's got its limitations.
You explained
It'd be nice if we all had a budget for some Keysight equipment or Roden Schwartz equipment. That'd be nice. Dan, you could probably set us up with some stuff too. But
yeah, if you need something tested, maybe I can help. But I think Joe has probably just as good of equipment as I do. Ooh. And would be able to do it much faster. But the one thing that when you're talking about antenna analyzers that I was going to talk about, because I use one because out in the field it's really easy to throw in trying to figure out, is it the right length, what do I need to tweak. The other thing that if you're on full design mode of an antenna, these actually do come in handy, or some other higher end, because then you can actually design traps if you're doing like a end-fed half wave and trying to create a trap to shorten up the 80 meter section, or being able to adjust things. So there's ways that it could come into play, but it's a lot more complicated to go through, and it's figuring out the insertion loss and where that insertion loss is blocking everything out to ignore that extra portion of the antenna. But to get a rough idea, I think the difference in price, once you kind of get to use it, and if you use it enough, it's probably pretty good for a first run on an antenna, especially when you're doing dipoles, random wires, stuff like that.
Talk about traps. Remember this piece of equipment? Millen grid dip meter. That's how you.
Oh yeah. Flashback to the 70s for me. By the way, Gary, you were talking a little bit about port 1 and port 2. So for those of us that may not be as familiar about that, we know that that's the different the two different ports on here. But could you tell us just a little bit about the significance of those, or what they're what they're made, or what those inputs are for, or what they do?
Well, port 1 is the generator port. I mean, this isn't a full network analyzer. This is a half network analyzer. A full one has, let me describe this one. This one has a generator and a reflection bridge on the first port. And So that's for measuring reflection coefficient. And the second port has strictly a receiver. It's a calibrated receiver, and it's tuned at the same frequency that the generator is, so that it measures whatever the generator excites. So that's the difference. It's a generator and a receiver, and a real full network analyzer is switchable. It has a generator on either port and a receiver on either port, so you can measure 4 S parameters. This unit only lets you measure 2, the S11 and the S21, which is the S parameter at port 1 and the S parameter of what appears at port 2 generated by port 1.
And as you said, one of the advantages there is you have additional capabilities like measuring insertion loss and things that you couldn't measure reliably with a single port in there.
Yeah, for example on that, you can measure filters. And something that I did last year before field day was I measured the filters that we were going to use at field day, the bandpass filters, and there's just like a screenshot of the measurement on the VNA, and it shows you how much insertion loss there is on the top in the blue line, and it shows you the SWR of the filter in the green line towards the bottom there. So that's an example of how you might use the 2 ports.
Well, you could also measure how much attenuation it has out of band, which is what you were mostly interested in, I think.
Right, which I did also, but I wanted to show the in-band ones there in that one. Sure.
Is the Nano something you would keep connected all the time, or just use it to test when you're changing your equipment or setup?
Not sure I follow that. I mean, you only turn it on when you want to use it. It's got no purpose. You can't leave it hooked to your antenna because your transmitter will blow it up.
Okay, so you would just use it to just test, but once you've got your antenna and everything set up right, you disconnect it and you'd hook between your transceiver and antenna.
Yep.
Not like an SWR meter that you might keep in line.
Yeah, it's not an SWR inline meter.
No.
Okay.
Let me make something about antenna measurements. Even with either unit, the antenna analyzer or the NanoVNA, if you measure your antenna at the end of a long piece of coax, it's going to be different than if you measured it at the antenna.
Mm-hmm.
Assuming that that the loss in the transmission line is insignificant, the SWR will be right. It'll be the same on both ends, but the impedance value will be totally different because that's what a transmission line does. It moves. It moves around the Smith chart, changing the impedance as you move along. It repeats every half wave, but that's so the resonant frequency of your lowest SWR is not the resonant frequency of your antenna most of the time. The resonant frequency is where the reactance goes to 0. It may not be the best SWR there, but that's where the resonance is, where reactance goes to 0. But at the end of the transmission line, that's not what you're going to see. The reactance going to 0 is going to be totally different than at the antenna because of the transmission line rotating around the chart, giving you different impedances as you increase or decrease the length of the line.
But would it still indicate what your radio is experiencing?
Oh, exactly. It's the end of the line. It's exactly what your radio is going to see. As I say, the SWR will be the same, but
right.
The absolute impedance is not going to be what you see at the antenna, and neither will, as I said, because it's when the reactance goes to 0. Like for example, if your antenna is too short, it's going to be capacitive. If it's too long, it's going to be inductive.
Mm-hmm.
But that's only valid at the antenna. It changes along the transmission line.
Okay. Is that like that, the video, I bet a lot of you have seen it, Standing Up for Standing Waves, where it shows changing the wavelength?
Definitely, yeah.
And that's you're talking about SWR and matching. That's what's why like antenna tuners at the radio, are there to match the antenna system, which is the antenna and the coax to to a transmission line, I should say, shouldn't not necessarily coax, but to together, so that it looks like a good impedance to the radio. Whether it's an efficient radiator might be a different story, but it's it's a good match to the radio, which is important for protection of the finals.
Well, yeah, typically because your radio will cut back power if the SWR
Yes.
gets very high, so you won't get out very well anyway. So matching to it, making your radio happy gives you more power, but you still get a lot reflected. Like I operate 5 megahertz with my 40 meter dipole, and it's infinite SWR, but yet people still hear me.
Well, we used to make contacts using light bulbs, light bulb for dummy load, and
Yep.
something.
Right.
Yeah. I had a question, but I forgot what it was in here. But so I was going back to the antenna analyzer or versus the equipment. Yeah, keeping it in line is something you can put with an SWR meter per se, because you're measuring forward and reflected power on the line. But this is more like you wouldn't leave your antenna analyzer plugged into the radio. Well, first off, wouldn't be connecting the other end of it in there, but consider it's a piece of test equipment. And like I said, I'm looking forward to doing things that Roger and others have done, and that's using it to tune and test the performance of like low pass filters, and probably with a nice clean or nice square wave on the output, it should be a good driving signal for us. And then but I'm building a number of small projects that involve filtering, and these types of devices really a very inexpensive way of getting the type of results that I couldn't get back when I was in radio. It was 35, 40 years ago. I could do those things, but it was very expensive.
There's also, if you're talking about builders, there's people are using this NanoVNA to characterize crystals. The crystal frequency, resonant frequencies and such, so they can match crystals to use them to make crystal lattice filters.
Okay. So looking at all the costs and expenses of setting up a ham shack, figure at first you're going to get whatever radio you might start with, an antenna, and then you get into all this other equipment. Where would you place the Nano in the sequence of equipment that people should get when they're building up their supplies?
Oh, I don't think not real soon. You gotta get your radio and just a regular SWR meter before you get anything else, because that's what you leave in line to see that, something happened, my antenna broke, or there's a bird up on it, or iced up, or whatever. You notice it real fast because it's always in line. Although the SWR meter I've got, and I think maybe most of them, except maybe for bird through line things, is that the higher the SWR, the more inaccurate your forward power reading is. In fact, with infinite SWR, instead of 100 watts, it's reading almost 200 watts. So it's when I get back, it seems like it goes out again, and it doubles the power. Which is not true. So it gets faked out with too high of SWRs.
Yeah, I had some radios back in my teen years, and I thought, wow, this is really performing really well, until I found out that that's not.
The other thing, Doug, is most of the modern transceivers have an SWR meter built right into them. So, I don't necessarily monitor anything other than the one that's on my radio. I have some others that happen to be in line, but I don't usually use those. I look at the one on the radio most of the time to determine that the antenna's okay.
Yeah, and the other thing on top of what Roger just said too is like the 7300 and 705, and I'm sure there's several other. that you can actually set for the band, and by click, you can set it up to do certain steps so that all of a sudden with a split second step, it'll actually go through your band and give you an SWR curve that is kind of reflected of what your antenna is. And then you can have an idea of, is something right? Did something go wrong? Or, does everything look okay? All right, it's tuned up. I'll go through it, so I'm sure there's other radios that also have that same function, but otherwise, yeah, just like Roger, if you key up and you see something, SWR is wrong, you're like, oh wait, am I on the wrong antenna? What's up? That's kind of the first key.
So that's great if you have a resonant antenna, but I've got a vertical, that's all I really have. And it's sometimes resonant. It's resonant on 40 meters and maybe 10 meters and maybe 15 meters, but it's considerably off on the other band. So I need to use an external tuner. And then having the SWR meter in your radio doesn't really help, because you need something downstream of the amplifier, or if you're going to use an amplifier, which I do. So, Doug, again, I think you asked a philosophical question, right? What's the right order to buy stuff? Normally it would be a decent radio, but you really want to put your money into your antenna. But the antenna, even if you put a lot of money into it, may not be resonant. So you got to figure out what to do with that. And then after your antenna, it might be an amplifier. And, I thought ahead, because I did not have an amplifier for many years, but I bought a good watt meter that went external to my radio that also has built-in, it's a vector watt meter. So it'll measure forward and reflected power, and it'll give you the actual impedance. So you could do antenna analysis with it too. So that's another approach you can do too. It's a high quality piece of equipment that I've had now for about 10 years. And it measures the power. It's downstream of my amplifier, and I can look at that and know very precisely if my antenna shifted or not. And that is in line all the time. That's nice to have.
That's a good point, Joe, because, a lot of people use automatic antenna tuners and things like that. And they'll tune into a very wide range of things, and your antenna might actually be broken out there and you don't realize it because it's automatic.
Or snow. With the snow, I've got a 80 meter tuning coil at the bottom of my antenna, and I can clearly see a difference now if the snow is out there, because now it's around the tuning coil on the bottom of the antenna. And I have to go in there and shift my settings. I don't have an automatic antenna tuner. I got a monstrous antenna tuner. It's a Palstar. It's a nice one, but it's old school with cranks and handles and stuff. It's not automatic.
But you know what the settings should be.
I know what the settings ought to be, and I can see that they shift. Yeah.
Right.
How does snow impact your signal and your antenna?
So in my case, because I've got a match coil in the bottom of it's basically it's a long wire vertical 80 meter antenna, but my antenna is not the right height for 80 meters. So the way you deal with that is you put a tuning coil in series with it.
Okay.
It's a big open wire tuning coil that I got from a guy who used to have a huge antenna farm around here, he nicely gave me this big coil. It's maybe 4 inches and it's big. It's 4 inches in diameter, maybe a foot long, with these, it's probably, double aught gauge. It's not wire, it's flat strap that's wound around on it, and it's exposed. So it snows out there, and snow just goes right up against that and changes the inductance.
I see. Now
so that affects the tune.
I see.
More changes the capacitance between the turns.
What was that? Yeah. Yeah, you're right. Listen to Gary on that. I'm full of it. Gary's right. It does change the capacity between the turns, which does impact the effective inductance at that frequency.
Now, is that something that a nanometer would be useful in determining if things have changed?
You could see it, but that's not going to do you much good, because, if you're in a contest, like some of us like to contest, right, Roger? Some of us like that a lot. And we don't want to be unhooking our stuff to hook up a NanoVNA in the midstream of our contest to see what's going on. You need something inline for that. And a bird's okay, but it doesn't have that level of resolution. But I mean, the meeting's getting hijacked, and I apologize for that. I was just pointing out another possible solution for what you're asking.
But it's good test though. If you see something acting goofy and you're not in, full on contest mode, easily disconnects, you hook up your NanoVNA, you see what it looks like, and something shifted. What happened? Is my coax full of water? That you start troubleshooting.
Mhm.
There's an interesting feature that I think is in some of the firmware in these devices, and it's a TDR or a FDR. Yeah, that's right. Analyzer near domain reflectometry or frequency domain reflectometry, and that was the thing that really tickled my fancy back when I started out my career in the test equipment lab. That you can actually go in there and have kind of a snapshot of the antenna system. So you can connect it to one end of the coax line. It goes up into your antenna, and this technique allows you to see what the impedance is down the line, including things like shorts and opens and pin. And we used to use that when I started out at Admiral back in the last century. We used to use those in the lab because we had like I don't know how many miles and dozens of miles of cabling, and every now and then the signals would go down, and we would be able to connect device up, and it would tell us, oh, at 123.5 feet there seems to be a short or a bump in the impedance, and to have that capability, maybe not as robust as a HP instrument back at that time, is really nice to have, because you can kind of see your system. And the one that I have here, and this one's built into my antenna analyzer, but I know this unit does this too, is that I can actually connect it to my coax here, and I have a window panel where I have bulkheads that go through there. That's how I connect from my shack to the outside world. And you can actually see the very tiny little bump where you can see the connector are. And you look at it, oh, that's about 6.2 feet. Yeah, that is. And and you can do things like that even with these little units. Albeit you don't have to do it every day, but it's nice to have.
So the NanoVNA has the TDR?
The F1 does, I believe. I have to take a look
Okay.
at that.
They all do, but maybe the F1 is a menu choice. With the H1s, you have to set up a transform. It's in the transform menu area, or you use the PC software that'll automatically do it for you.
Okay.
Barry, have you looked at the accuracy of that? Do you know how close they are?
Yeah, it depends on your calibration, but and the frequency range. If you use the full span, you get more accuracy than you do, but there's a length limit. Where the transform runs out. So it's not all things. You have to be careful. Like you use low frequencies if you want to get the very long piece of coax, and if you got short coax or moderate length coax, you got to use the whole 900 megahertz sweep range in order to get that accurate to centimeters.
Yeah, I know you're too in the weeds there, but do these units use frequency domain, which sounds like it might be if it's sweeping through frequency? It's like time domain is sort of like a radar pulse where they'll ping something and then they'll be looking for the return, whereas the frequency domain does more of the sweeping. And I know on my rig expert, they use frequency domain, and like you said, you need to go and set a wider sweep length to get more length for that.
They're always frequency domain with a transform on it that it's a 4
that's what I thought. So when you said transform,
to it. The impulse ones, you need an oscilloscope and you need a impulse generator, and there was something on I think Tinder or something where a guy was selling some. They're basically some. I think it was a pulse generator made from some high-speed logic gate or something that, so you can see the reflection come back. You see the original pulse and then you see the reflection, and you can measure the time difference between the two of them, and that's your length. But I think you also have to count in the velocity factor of the line, or else or else you could be way off, because it's,
we got to do that with the frequency.
no matter what, you have to enter the velocity factor in as part of the transform.
I find it's kind of handy running it occasionally on my antenna system to see if there's any significant changes in there, and it's just another nice feature that you can do with these things.
Yeah, like if you kink the coax too hard, or a car runs over it or something like that, you'll get a good bump in the.
Close the window on the.
Oh yeah, right. That same thing, right?
I've got another piece of equipment that does have a TDR functionality built in. It's, again, it seems like I'm trying to hijack the meeting, but Ralph, you asked. So I've been able to track down within about or so on a 100-foot length, just when I have an impedance bump. I've been able to find bad connectors about 100 feet off from my shack with it. It's really, really useful.
Yeah, Joe, you cut out just at the beginning there with what instrument?
Okay, so I have another, the AIM analyzer I mentioned earlier, made by Array Solutions. I have one of those, and this is not an AIM meeting, but since you asked about TDRs, that has a very nice TDR functionality built in, where I've been able to track down. It's within about a foot on a 100-foot length of coax. So I've been able to get very, very close on impedance issues on my coax with that. On that one, you also have to enter the velocity factor of the coax. So so you're looking at, I think the velocity factor is the main thing you have to enter. Once you get that entered right, the distances come out very accurately.
So this is helpful, even though you may be going off on a different equipment, Joe. It's still very helpful for us. We had an instance with our cable TV where the cable was physically cut. Would a device like this work on any coax?
Yeah.
And I tried to convince the guy that when he buried it, he stuck it in the ground with his shovel, and I know that it's physically injured around this point. He said, "Oh yeah, there's no way to detect that. Our meter says it's fine." Like,
well, that's not right.
Yeah, I think there's better equipment out there.
Yeah, well, they're not the one I have new goes for about $1,000. I bought a used for about $500. So I mean, it's beyond the scope of what we're talking about here. But I had a specific need for it. It's very nice if you need it.
Do some of the nanos have that feature?
Yes.
To detect cable damage. And what is
well, it's the TDR function. So that's
okay.
You want to be sure the thing with that is that if you have you want to be sure you don't plug it into the end of an active cable, a signal coming into the house.
I see, there's no energy on the cable.
Yeah, exactly. But there's the cable people, they have WaveTech devices, brand devices, and they can definitely measure things like that.
I think it depends if they have the knowledge
or the desire.
Yeah. Okay.
Yeah, the installer is not the same, not the same knowledge basis, a troubleshooter who would actually know to go out in the field and what to look for.
It did escalate to level 3 before they finally fixed it, whatever that means.
Well, sometimes, if you come in there and you feign interest in that, I go, oh, that looks really interesting. I had an AT&T guy on the hook for a couple hours there as he was stringing my U-verse about a decade ago and showing me his meters. And, look at the back panel here. Oh, that's pretty cool.
Ooh, learn all kinds of stuff.
But yeah, definitely that's really what it's good for. I was going to add that on my I have a 80 meter end-fed half wave, and that's about 132 feet or so, from a feed point to the end. My yard is not conducive to that, and I had it. And if you got to do that, if you have to like bend the antenna, you really want to do that at 90 degrees, right? Like an inverted L or things like this. Well, I didn't do that. I did the Zorro. I did a Z, but that was, at least as I stand right now, that was my best way I could get everything in there, and it actually tunes really well. But I can put either my analyzer or the NanoVNA in there, and I can actually see, like I said before, where the cable reaches my bulkhead connector, just a little bit of a blip, and then it goes out, and then it goes up to the one point where it hits the Z, and you can actually see that change a little bit in there. And it's just really pretty interesting. And especially if you have a cable problem, that's indispensable. You know, you're going to know you either have a cable problem or you don't.
And you said again, that's a function, that's the TDR function?
Mm-hmm.
Okay.
Yeah, it's like Gary said, a transform in there, because they use something called the frequency division, which is, we're talking things, but it's basically the transform. But it gives you the idea. It plots out the reactance components across the frequency range and translates it into a point distance.
So that sounds really helpful. And I encountered this with Bill, KD9WEW. We put an antenna in his attic, and there wasn't enough length, so he had to bend the ends down. We really have no idea what that did to the signal. It's able to work just fine,
Mm-hmm.
or, you know, so as far as he's been using it, it works.
Mm-hmm.
But we've never had a way to actually analyze and determine what happens when we bend that. So it sounds like this meter would help us understand that a bit more.
Not necessarily, but typically with an antenna, you never want to bend it back on itself, because that cancels the wave. You just want to bend it in some other direction that isn't bending back on itself.
Yeah, don't do what I did.
Right, it was more like almost like a V. It was kind of straight, and then the ends dipped down to a V.
That's fine.
That's no problem.
Fine.
Okay.
I mean, mine in my attic, they go at right angles when they hit the wall, you know, because they got no way where else to go. And I'm probably all these equipment, whether the antenna analyzer or the NanoVNA, when you hook it up to an antenna, you sometimes get weird readings, false readings, because it's picking up signals. Shortwave broadcasts, for example, around 9 megahertz, 913, they're pretty damn strong. They're like 50 millivolts here on my antenna. So it can really screw you up sometimes when you pick up signals, and it just makes you confused as all get out.
You know how to deal with that, Gary?
Not too well, and so you gotta be careful.
What was your suggestion there, Joe?
I'm suggesting I don't know how to deal with it. And I was wondering if Gary had any tricks of the trade that I don't know, or maybe Roger. I don't.
You need a big chamber.
Faraday
Right.
cage.
Yeah, right.
Faraday cage around all your equipment.
And it's about 60 feet high.
Or a band reject filter to get rid of those.
Yeah.
Yeah, a suck out.
Yeah.
I see. You know,
Which
but
is kinda-
future topics, I'd love to have a future Hams Helping Hams topic on hidden antennas or attic antennas and things like that, because that's a fun hobby right there.
Yeah, we've got a lot of interest in antenna building, not only for Hams Helping Hams, but just generally in the survey that we put out last fall. It continues to be, and it's a topic that, you know, most of us can learn a lot from. I mean, I'm certainly learning all the time. Like, you don't want to make the market a Zorro there when you're putting up antennas, but anyway, you got to do what you got to do. But anyway, that will be definitely one of our considerations in there for. By the way, there are some antennas that actually work best with a slight bend in there too. I mean, that they're designed to, you know, to match that way too. So always things to learn about our hobby.
So there was a good presentation this weekend on the hamcation. The Orlando was done virtually, and there was something on what to do about, you know, stealth, or what to do with when you can't hardly put up an antenna or whatever. There's these ones where they put them up during the day, and during the night, and they take them down so the homeowner association doesn't see them. And but this guy was a Brit, and he essentially put antennas outside for the winter for the contest season, and during the summer he took them down and just left his VHF antenna up on the house, so that he used push-up poles and made verticals mostly, but he also made like bobtail curtain arrays out of it. He had a lot of very interesting antennas, but he said indoor antennas, don't like them.
Yeah, and that presentation should be on YouTube as well. The Hamcation sessions in there. So
yeah, it was recorded, right?
Yeah, I actually for Doug's and Bill's sake, there was a number of, I attended a number of the youth track sessions in there, and I'll send you guys an email on it. And those are also on YouTube too. A lot of interesting things about scouting and getting youngsters involved in the hobby.
You know, just a couple of basic things. If you decide you're gonna buy one of these things, you know, these little tiny SMA connectors, they're really fragile. They're only good for so many connections, and so you probably want to also get, you know, something like this, a flexible cable that you can connect this to, and have something like you know, an SO239 connector here that you can connect to, and not put so much stress on one of these things all the time. And in addition to that, if you don't have them already, you might buy a whole little kit of adapter cables that go from SMA to all kinds of things, you know, BNC, you know, all the different connectors that you might happen to use. If you have all that stuff already, then you don't need to buy that. But you know, I find in trying to adapt it to, you know, antenna connections, filters in and out, attenuators, all that kind of thing. You need some stuff. The other thing is, you know, when you start with this, you have to literally calibrate the thing right at the SMA connectors.
No,
But
you
then,
don't.
of course,
No, you don't.
well, you don't have to. But
You
what I was going to say,
calibrate them at the end of your pigtail.
well, that's what I was going to say. If you add in something like this, then it's not calibrated anymore. You
Well,
got to
yeah.
calibrate it basically at this point.
I
There you
always
go.
I always leave these cables on. I never
Yeah.
take them off, and that's where I calibrate at the end of. These are RG3 16 cables. They're a lot better than the ones that come with the unit. Also, they make this. See these little male to female on the end here. This is connector savers on the end here. So it just extends it a little bit, and you wear these out, and then you put a new one on.
Yeah, SMAs are typically good for what, 500 maybe insertions? I don't know, something like that.
And a lot less if you let the center conductor rotate.
Yeah, and maybe from China, not that much. I don't
Oh
know.
yeah, these aren't Amphenol's. I think Amphenol's are rated at 500. These
Yeah.
are probably not quite that nice.
I doubt it.
So yeah, so what were those? Was that was an extender, or so it's basically a yeah, it's like it would be like let's see, it would be a male to female, right? So you screw it in there, and that's a really good tip though, because you can then, you know, wear them out and just unscrew it, and do that 300 times. You know, so good. You got to have to remember to do that.
Hey Gary, what cable was that? RG315 you said?
316.
All right, thanks.
It's a double shielded Teflon cable.
That looks like the connector I have from my HT to my bigger cable.
Right. Yeah.
Yeah, I think it's a lot easier to get one of those cable extenders than having to disassemble your unit and replace the connectors in there. Cheap insurance. I found out, I don't know how I got this. It was included in my unit, and I don't know if I had got a coupon code or what, but it was kind of an interesting addition, and it was they call it an RF demo kit, and it's a small board, and it has broken up into different sections, and you can, you know, they're kind of like showing you, if you connected your NanoVNA to that, what the traces would look like. So there's you know, an RC network, and our basic pure resistance, bandpass filter, band reject filter, and attenuators and things like this. I don't, and on the back is a Smith chart, so you can figure out how that works. But the thing is, I looked it up there because I had gotten this for free. I'm sure it was included in there, and I had some special price in there. But I looked it up on eBay, and they're about $18 now. So I don't know if they're really worth that, but it is kind of a nice tool to to see how they work.
I think AliExpress has them for about $5.
Yeah.
Yeah.
RNL Electronics, where I suggest people buy these H units, sells a little test jig, if you would. It's a thing with a bunch of sockets and SMA connectors on it that you can arrange to, the shorts, and you can calibrate right there, and you can put your little component right at the very thing, right at the point there. Another thing I want to point out is that because I use these cables and they end up in a male, and all my calibration standards, I've put a bullet in, a female to female bullet in, so that I don't wear the calibration standard out either. I'm wearing out just that adapter.
Yeah, those calibration standards, those are the things that they come with the unit. But you're right. You use them often enough, you don't want to wear them out. Another good tip.
And another thing is, at least the ones that I got, you can't help but rotate the semiconductor when you attach those little boogers to it. So I bought a new set that has an extension on the ends that you can grab so it won't turn the center.
Mm-hmm. Yeah, I've got the same challenge with my my SDR play, my RSP2, that you have to be really careful with that because it's got the SMA connectors in. So I think I'll be ordering some. Oh yeah, so you touched on where a good place to purchase these are from, and the reason for that, well, I'm sure I'll let you explain your reasoning, but there's so many. If you go to Amazon, for example, you can see a lot of entries in there, and they're all over the place. I don't want to say counterfeits, but there's different sets of features. I had a situation where I bought a replacement card for my 3D printer, and there were knockoffs from it looks like it was the same unit, but it was made by another company, and they were using chips that were claiming 512K capacity, but they were 256K parts. They were labeled that way, so you have to be careful with that. So finding a good place that you can trust and knowing where you get is important there.
Just because of that system's no moving in.
Yeah, there's a wide quality spectrum in these clones, and the best units come from the original developers, and they may cost a couple bucks more, but you're sure to get something that works. This spectrum analyzer, this tiny SA, there's been a whole bunch of clones on it now too, and they all fail the self-test because they don't know what they're doing. And but people buy them because they're on Amazon, and they're where and get them cheap or get them fast. And I got this from China, directly from the Zinco store, which is the Huygens store. So you get the real stuff. And RNL Electronics gets them from there. So they're the real stuff. They buy them in quantity, so they can resell them for the same price as the list price of single units.
Is there a way to detect a knockoff on these?
Unfortunately, on eBay, you look there, and they're all using the same pictures, probably from the original.
Oh, yeah.
Bet on that at all. Amazon at least will stand behind their things. If you say, I got a piece of, a clone that's defective, it's not as good, you can return it and get your money back. But good luck with eBay.
Yeah, good point. Because I have seen pictures of real versus clone, but you're right. If they use real pictures, you don't know till you receive it.
Exactly. The one I bought, this one here, is a worse clone. It's called You know, there's various levels of clone, and this one has no shielding on the inside, but it works fine enough for me. I didn't send it back. The guy actually, I got it for free because he refunded the money and said didn't want to get it back. So
Didn't want to get his $2 cost back.
right. So you know, once I proved that it wasn't what was in his pictures, eBay gave me the refund.
Okay.
Yeah, it can be very hard sometimes, you know, sifting it out. I do like that tip there, you know, going to the original manufacturer, and it's nice to have a supplier. Now, RL the Electronics, they're in the States.
I think Ohio.
Oh, okay. Yeah.
Yeah, they were pretty quick shipping. When I had it after your first presentation, when you did it, I jumped on there, and I think it was only 3 days later it was sitting on my door. So
Yeah, they're very
only a day behind Amazon.
right. They're people are pretty happy with what they get from them and their prices and their service.
Yeah. Well, this is great. We've covered a lot of topics, and you know, I suspect that you know, we'll be coming up with new ideas. I want to thank everyone, and I'm not cutting this short. If we want to continue, that's fine as well. But I really enjoyed the time here that we've had together, kind of, you know, kicking around knowledge and tips and kinks and things like this, and looking forward to doing this again on a different topic.
Hey, Gary, do you have a good manual source that you can recommend on this? Because I know that the documentation that comes with it is not good, that maybe people could go to and read up a little bit on it.
On the NanoVNA Groups IO, there's a guy who wrote a manual for beginners. So it's in the file section there that would be useful. But I think a lot of people find a lot more use in the YouTube videos where they can see pictures, people doing something with it, showing how they, you know, do this or that. But I think, you know, the quality of the videos or the video a lot of times, because, you know, it's out of focus and it's a challenge sometimes, but it can be useful. Like mine's out of focus. Oh, that's good.
Well, fortunately, this isn't going to be shown anywhere. So.
Well, this has been helpful. You've answered my questions. This helps me know.
I got a little another thing about measuring antennas. If you're up there at the antenna and you got this ray at the antenna, guess what? It's part of the antenna. So it changes things by being there, and you touching it, and you're adding extra counterpoise to it, if you would, by you touching it. And if you got the the cable hooked up to it, it also screws things up. See, I put a ferrite clamp on the end there to help isolate that, and people have found that it's just holding the unit, and when you're hooked up to the antenna and such, you can get a lot of differences. So what I did is I hung this on the antenna and then backed away from it, and they used no, the best thing would be to use a wireless connection to it, and some people have modified theirs, especially the H4s, have the capability of hooking up to a UART there, so you can hook a Bluetooth up to it. A terminal, a serial Bluetooth, if you would, that has no special requirements, and so that you can remote the connection, if you would. That little antenna I showed, that Mini 60 has a Bluetooth in it, so you can back away from that too and measure it on your smartphone if you want.
Now, these units can be field updated too, right? The firmware on them, or at least some of them can.
The firmware has matured. It isn't coming out very fast anymore, and in fact, the NanoVNA app will has a function in it. It says upgrade firmware, and it knows where to look, and it finds the most recent one and says, you got to make, it doesn't tell you that you got that version already. You have to look at your unit and see what version's on there on the version screen, and to know whether you want to buy it or upgrade it. This spectrum analyzer one, though, is in rapid development right now. It has not matured. They keep adding features and improvements to it. So until it runs out of space in the flash, that's about it. These ones here, the old 2.8-inch ones are not as capable as the 4-inch ones. It has a bigger flash memory processor, has higher speed and more resources. So it has further advances that they made with that like more points per sweep. This one's limited to 101 points, while you can get to 400 or something with the bigger one.
I like that, more capability, with either at the same price or just slightly more expensive in it. It's the software aspect of this is just revolutionary. Same with software defined radios. You can, to an extent, to a limit, you can actually go ahead and almost never be obsolete. Limited only by the hardware that it's based upon in there. So pretty cool stuff. Well,
Hey, Gary.
Oh, go ahead.
Well, I was just going to say, Gary, I know you touched earlier on maybe talking about what the signal source was like. Oh, there we go. Gary's sharing his screen.
Oh boy. Wow, that's big. So this is an amp. Well, I'll let him explain what it is. To me, it looks like a screen.
Well, this is why you don't need to buy the 4-inch one. You can just buy the 1-inch screen, and then
Right, because it communicates to your computer.
It's interesting. You can't push the space bar and unmute yourself when you're sharing.
Oh, you have to use the mouse.
Yeah, you have to click your thing here. So anyways, this is the written by one of 11, which is was one of the developers of the firmware of the NanoVNA, one of the volunteers, one of the people that didn't develop it. She's a great programmer out of England, and she's done a lot for the spectrum analyzer version too. But anyways, this is a really nice program, and here's the upload firmware. You can choose between a 1 of 11 and Dislord's 2 versions there. This is the H4 version. These are just the H version. So there's this is the best program to get to run with it. I mean, you've got all these exporting functions, and these little gray lines here are the bands. That's the 432 megahertz band, and all the high HF ones are all crammed in here. You can now I spread it out here. So here's 10 meters, et cetera, et cetera, et cetera. All these little gray bars here. You can turn those on or off, on or off, and it also has LC matching functions here. Once you get a curve and you can get a match. You can talk, type in the terminal control commands on through here too. This got everything. This programming. I guess this is the velocity factor for the TDR. Oh, misspelled dielectric. But anyways, so I just thought I'd show that because it's very, very useful. What's this info button? Oh yeah.
It looks like that one allows you to, it probably is progressively doing its sampling across the area instead of limiting you to the 128 or whatever.
101 points. You see here, this one is different than the first one of the programs, which it would do segments, which would mean doubling the 101 points each segment. Well, this one just tells you how many points. You can go up to 25,600 points. This is more straightforward.
Now, this doesn't magically give you better resolution bandwidth, does it? Or are you still limited?
Yes, it does. you divide your frequency span by the number of points, and that's your frequency resolution.
I'm talking about the resolution bandwidth. That's what I meant.
Well, here's the resolution bandwidth. You can go 50,000 down to 10 hertz.
I thought the hardware was limited to much higher than 10 hertz.
Then, no, not the NanoVNA, because it's like an SDR here. You can do anything you want.
That's awesome.
The spectrum analyzer is limited by physical band, filters.
Oh, you know what? I'm getting okay. I'm getting mixed up here. I am thinking it was a spectrum analyzer.
Yeah. Well,
Which
there's
very good on that.
a similar program for the spectrum analyzer. It looks similar to this.
And where can we get that, this program, Gary?
Free. It's free. You get it through the. I'm pretty sure it's either on the groups.io, NanoVNA, or I think that's where you find it there. Just look by, or just Google NanoVNA -app 1 of 11. That's their handle, 1 of 11, and the other one's Dislord. Here, those were the 2 big developers, other than the original, other than Hugin. So let's see, stop share.
Yeah, the code's on GitHub.
Yeah, I see that. There's a lot of stuff on GitHub.
GitHub's how I work too.
Well, this is great. Well, folks, I need to step out. I don't want to cut the conversation short. You can continue certainly, but I need to wrap it up. This has been really helpful. So thank you for your time and insight.
Yeah, thank you for joining us. It was a lot of fun.
All right. Well, I'll catch up with you later. If I miss anything, I'll catch up at a future meeting. But for now, 73.
Yeah. Okay.
Take care, Doug.
Bye, Doug. So in the few minutes we have left, any other questions or other things you want to talk about? Nice equipment, Joe. I tell you.
Well, a little thing here. If you got big fingers and it's hard to tighten the SMAs, there's these little printed rings here that you can slip over the end, and it gives you a nice big grip then.
Enough torque to break it.
Yeah. Well, SMAs are supposed to be torque wrenched on to a certain amount.
If you go to the right torque on these, you'll break them. These won't handle the official torque.
You're probably not. You're probably right.
I stopped till it's good enough.
Right.
Yeah, I know, Gary, you mentioned earlier that the signal source on this is not real. It's not a sine wave. It's full of harmonics, but it is a nice signal source. It's around 0 dBm. If you put it on CW and select a single frequency and listen to it, for example, on your receiver, it's extremely stable. So, you can use it as a signal source. You could use it with switched attenuators or fixed attenuators and that sort of thing. It just isn't real clean.
Yeah, I mean, you're only listening to one of the harmonics, the fundamental of the harmonics. The rest of them don't matter.
Right, they don't matter.
Although the fundamental is probably the only one that is relatively controlled in amplitude, because the waveform changes from pretty a square wave to more of a trapezoid the higher the frequency you go. I mean, it's just coming from one of those little SI 5351 multi-oscillator things. So that's...
Yeah.
That's your square wave, and then what? We probably have LC that's shaping the waves at the higher frequencies.
No, there is no. I mean, it's just stray capacitance is what's shaping the wave. They do nothing to try to clean it up because they depend on the third harmonic to get to
The
900
booster
megahertz.
range. Yeah, yeah.
Because it's only and even still, these little silicon labs parts are only guaranteed to work to 200 megahertz, and this unit uses it to 300. So it's really taking a risk there. And you can change the switchover frequency if you happen to have a discontinuity near 300 megahertz. You can change it to something lower, and then it's smooth. That's another option in the menus.
Yeah, it's a really widely used chip in a lot of ham projects and test equipment. I mean, the budget test equipment and
Right.
things like that. In fact, I've got a project that I'm working on now that I have to actually filter the square wave to get a clean sine wave, and which hence goes back to the low pass filter that I was talking about earlier in here. So my flex will not like to have a square wave feeding into the 10 megahertz input there. So.
Oh, no.
That's great.
Well, I sort of got to go to another call here in a couple minutes. So,
Yeah, I know. We're actually we'd scheduled for an hour and they didn't know how it was going. I think it went well. I certainly learned a lot. If I can come out to a talk or a presentation and come out with a couple of new things for me to look into, I consider it a success for myself. And think that we had a good first meeting, and as we go on to different topics, other people will be coming in and out. I think this could be very good.
okey-doke.
All right. Well, thank you, Gary, so much for
Thank you,
being
Gary.
Yeah,
being
thanks a
one of
lot.
our many experts tonight.
You're welcome.
All righty. Well, good night. We'll catch you at the meeting on the 2nd.
Right.
All right.
Thanks, Ralph.
Hey, good night.
Thank you, Ralph.
Bye.
Thanks, Ralph. Bye.